3D printing, or additive manufacturing, is a process by which three-dimensional design layouts can be used to make products by piling two-dimensional printed layers of materials to a cross-section of the design layout and stacking them one over the other. The layers are made by using either liquid or powdered material, which is layered and melted into place. Additive manufacturing allows for rapid creation and replacement of existing parts of any technological, mechanical, and sometimes even biological products. Today, 3D printers function in various ways, the most common of which include manufacturing using plastics with methods such as stereolithography and fused deposition modeling. Recently though, there's an increasing use of metal products being made using selective laser melting and sintering. In additive manufacturing, 3D printing systems allow anyone with a printer, CAD equipment, and access to the adequate materials to construct a variety of parts very easily. With this rapid prototyping technology and tools, we can replicate and change products as we see fit in order to form new designs and customize old ones to our liking. The use of 3D printing will increase innovation and manufacturing in ways we have yet to explore by essentially making manufacturing independent of the assembly line and reducing the need to transport materials long distances. Complex, multifunctional components are going to be able to be built in means that traditional manufacturing cannot. It will also make it easier to share, change, and rebuild our designs, similar to how software developers use open source codes. This can be seen in modern day as maker culture, where individual arts and craft skills are combined with CAD designs to fabricate parts for use in do-it-yourself applications. The movement targets everyone interested in designing and building real-world projects or testing, including but not limited to engineers. Maker culture has the potential to bring a vast amount of experimentation and broad perspectives to product design, and it can allow communities and remote locales to manufacture any products on their own. However, maker culture is geared towards letting everyone use design software and principles. The issue arises when we consider ensuring the safety factors, meeting constrained specifications, carrying out complex physical analyses, and most importantly, the ethical issues concerning liability and intellectual property. These are largely ignored in this approach since that task has traditionally been reserved for engineers in their respective fields. The challenge facing modern day engineers is how to keep up with this changing attitudes towards manufacturing. Manufacturers must uphold and encourage the use of appropriate safety protocols, design guidelines, and protection of intellectual property rights. The current lack of regulations leads to a number of problems. First is the ability for unauthorized individuals to produce highly regulated products like guns. Due to the inherent open source nature of 3D printing, access to these specific CAD files will be available to everybody, making it difficult to control. Second is for failure of the manufactured parts in determining liability in a manufacturing process where anyone can make changes. Currently, it will be difficult to determine whether the original designer, the printer manufacturer, or the material supplier is accountable for any loss incurred. Especially with 3D printing moving away from being simply a rapid prototyping method to being a suitable alternative to traditional manufacturing, liability becomes a more prevalent issue. Third is protecting intellectual property rights of designers. Local manufacturing and shared designs can lead to copyrighted and patented designs being reproduced with no knowledge of the owners of intellectual property. These are problems that must be addressed as the 3D printing phenomenon begins to grow. It is projected that the 3D printing market will grow from $3 billion in 2013 to $21 billion in 2020. With there already being conjectures that 3D printing will ultimately lead to the next industrial revolution, it is imperative that engineers update current codes and regulations in order to address the presented issues. By doing so, we can encourage maker culture and take full advantage of the benefits offered by 3D printing relative to current traditional manufacturing.